Okay, so it's been a while. First of all, let's not question it. Um, I've been wanting to do some content for a while, regardless, and I was kind of playing with a little scripting lang, and it's probably not gonna go anywhere officially, but it's just some fun and maybe some kind of like interesting content you guys can watch too. Um, so I mean, I wrote a version in C# that kind of works, and it does all of these things here. So I'm like, um, essentially trying to like transition it to C++, just purely for fun, so I could maybe make a video and post it up piece by piece. And yeah, so if you're new and you don't know anything about scripting languages or just language creation in general, um you essentially have like 3-4 phases. Like our first one, we're gonna lex everything. So all of these little, what we call tokens, get turned into like some form of code, essentially a representation of it, what that token is. Then we like feed that into what we call a parser. So like that will make some sense of these tokens, and then we'll spit out something we call abstract syntax tree. And that is essentially a more complex representation. So it will turn it from, a couple of tokens, a token that's a keyword, an identifier, I guess a symbol for the equal sign, and a number, yeah, into what we might call like a variable declaration. And our variable declaration will consist of, an identifier for our x, which is where we like store it or whatever, and an expression, which is 10. Um, After we've done with that part, we then, for the style of language that I'm going to be working on, we're doing a kind of I forget the proper term for it. It's like a kind of a virtual machine. You kind of transition it into instructions, which you then kind of like process, which is, I could be wrong, so apologies if I am, but it kind of works in a similar way to like I forget the name for it, like the way kind of CPUs and instructions work in a more I forget the name of the language. In a more low level language anyway, that a lot of the programs work on. Um Regardless, we then transit, so that's like our code gen phase. And then you have the virtual machine, which takes those instructions and processes them, right? So it's like, yeah, we have a lot to do here. I've already done it. We're just going real simple. We're not optimizing, and purely for fun, like, so yeah, you guys get to see it. I get to write some code, and maybe you can learn something from it. Maybe you can't. Who knows? But either way, first stage, we're gonna need a Lexer class, and we're gonna need a parser. So we'll just do that as well. We're also gonna need a we're gonna need token as well. And let's just start off in here. We're gonna use a struct for this one, and we're probably gonna need an enum for our token type. Let me move my keyboard a little bit. There we go. Now let me just copy my token types from my C# version. Make this a little bit easier. Yeah, so it's not supposed to be a tutorial, this isn't, but maybe you could use it as a tutorial, maybe you could just watch it for fun, who knows. I don't know where this will be in terms of like that kind of stuff. Either way, so our token types, these are obviously like different representations of symbols in our file. So we just close all this. You got your let here, be classed as a keyword, numbers, boolean, strings, so on. Okay, so here, actually don't need this. Yeah, token type. And what else are we gonna need? Probably a line, and let's say string. We'll have the text representation of it. Do we need the line? Did I sell the line in the C++ version? C# version even? I did indeed. Okay. Expected identifier. What? that because it's too big? No. Is it just too many bytes for the item? No, I don't know what the hell's going on there. Oh, conflict. Okay. So okay, in Alexa, we now need a few things. What are we gonna need? We're gonna want. Okay, we'll do that. We're gonna need a vector. A CD vector. Why is it importing like that? There we go. We'll store a list of tokens. And we're gonna want to store probably, let's see, the string, source code, opposition, and our current line. We'll get rid of those. Yeah, and we'll pass. Yeah, it's already there. Let's see the string. Oh my god. Yeah. I'm going to disable this warning. I don't really care about it. So yeah, we'll pass in our source like that. Basically just to initialize everything. Okay, and now we're going to need a couple of little helper functions. So yes, we'll take that one. We're going to want a char peak of that const. Okay. Skip white space function. That's actually quite a good autocomplete there from AI. We'll take it. I hope you guys don't mean that, but it is what it is. Okay. Now, okay, we're gonna need. We'll make these ones here private, and then we'll essentially create a Lex function. And here we're just gonna do yeah, while we're not at the end. What do we want to do here? We'll skip our white space. If we do hit the end, then we have the tokens array, right? Yeah, tokens pushback. Can we do it this way? Token type. Oh. Get the structure of token type. Sorry, token. Might need a constructor here. Let's make that the last parameter. So our text for it. Line. Okay, so why doesn't it like that? Oh wait, this is supposed to be token, not token type. It's in place back instead of pushback. Okay then. Okay, so let's just break the So we'll look at our first token. And then I guess here we need to see what our token is, right? So if it's, yeah, if it's alphanumeric, why does it? It's alpha or, yeah, underscore. Then essentially what we'll just do is, guess that will work. Now down here, oops. Yeah, we'll just make a consume identifier function, I guess. And this would probably keep things easiest, I guess. So track our starting position. Okay, what is this doing here? Yeah, I mean, we'll just do that for now, and then we can continue. Now we'll want to do probably numbers. So if, yeah, std is digit. Yeah, we'll do that. And then otherwise it'll most likely be a symbol. Maybe what we'll do with this one is try consume symbol. Otherwise, do we throw? I haven't really worked with exceptions in C++, so I'm not sure how they really work properly, but I assume I can just do like regular try catch stuff. So now we need these two functions. Token consume number. And this one needs to be a bool, and we'll just, yeah, like that. So for consume number, I think it's basically the start is same as identify. Yeah. Just relying a little bit on AI here, but it's fine. Now for this one, yes. Auto complete to the heavens. So we got the plus, the minus, is equal. Now, maybe we want to handle plus equal, minus equal, start equal, slash equal. And for those, okay, that's a little bit gross. Yeah. Maybe we want like we have, let me see. I suppose we don't have an advanced function. It's fine though. For now, like I say, we're not gonna care too much about doing things the most optimal way, so we'll just auto-complete all that shit. And I think we're missing a few characters here, but it's fine for now. Okay, network control, pass return of value. Actually. Okay. Now. I believe that should work fine. So, to test our theory, our next stage would be to essentially read in our file. I don't remember how to do this in C++. Read the file at the path. What's the hotkey for this? This one? No. Generate a new code. Oh, Control L, is that? Control I? There we go. Yeah, let's go, baby. Let me just test that actually works. Does it read my file? Okay, it does. Okay, perfect. So what we'll do real quick is just return a ball, and we'll just do false string line. Make sure. Okay, is that really a thing? It is. I'm pretty sure there must be a cleaner way than that to do that, but it is what it is for now. Okay, so if read file. Okay, now we can basically initialize our Lexer. How do we want to do this right now? Lexer equals new. We'll just do it this way. And we'll pass in the source. Lexer. Let's change the capitalization on that function real quick. And then we'll just quickly make another function, print what dump tokens. Okay, why doesn't it like this? Token type. Oh, it's because it's an actual enum, isn't it? I'll just convert it to an int for now. See what happens. Yeah, it's not a member of STD. What? I need these. Okay, unexpected character. So, what equals character? It's 61. So even though it's a char, why is it now outputting as a string though? So, okay, what we'll do, if C equals this, hit the breakpoint. Okay, so see here is an equals sign. Okay, we do that, we break. All this 7, so just to check. That's equals. Should get skipped. Now it should be. Oh wait. Let's see. Okay, and now we got string. So what we'll do, I guess maybe we do it here. Oh yeah, it already knows. It already knows. Okay, so what we got here? Okay, first of all, let me see if I can. Ways PC package. Um, wait for that to load real quick. And then we're gonna install, I think it's called Magic Enum. Wait, I think this will allow us to essentially convert our enums to strings. Yeah. I think we can literally just do this, install. was that little message? I have no idea. I think that's all I have to do. Maybe. Is it after? Ah, yeah, there we go. Let me link it here. Reload. Push. Now we have Magic Enum, and then it should just be. Yeah, enum name. Where are we? Main. Dump tokens. But maybe for the sake of it. Nah, it's fine for now. Screw it. Throw you up here. And it's what? Magic enum name? Hell yeah, brother. So yeah. Now, I don't know if you guys can actually see this. Oh god. Right. Console font, if we just up this a bit. Yeah, here we go. So like I was saying in the start, if you're not familiar, essentially we've now tokenized this. So we got identifier let here, identifier x, we've got equal number. The one thing we're actually missing is something for keywords. So let's make a. Can we make a vector? It's like a hash map. Oh, I'll just make a vector. Be fine. Vector of keywords. Can you do string view technically faster? I don't know. So we'd have let for if else. What else did I have my other one? Actually, I might as well just copy the list of strings. For now. Basically, when we're now consuming a identifier, once we processed it here, like this, yeah, here we go. If it's basically in our keywords list, then we'll return it as a keyword instead of an identifier. Simple as that. Yeah, keyword let identifier x. Okay. So now we move on to the next part.